The greatest threat to our planet is the belief that someone else will save it or fix it. Good afternoon, everyone. I am architect Gunjan from Anandam Design, and thank you, Jose and the team, to give us the opportunity to be here. So we are all here engineers, architects, designers, technicians. We all know what sustainability is and what is the problem that our current situation, current generation, the planet is facing. We being designer, we being architect, we got the opportunity to work on smart cities, right? And we went into the deep root to understand how a sustainable system can work. We worked in Panjim Smart City design, we worked in Chandigarh Smart City design. We designed the efficient infrastructure, we designed the road layout, we zoned the built and unbuilt structure, we did the landscaping, and then we came up with the solution that yes, this problem can be approached with a very dignified solution. We as designers, we talk about the build structure because that consumes 40% of the energy. We are showcasing two of our designs that is based in Bangalore, that is on an institutional stage, at a very execution stage right now, and we would just justify how we are using the correct technology, the correct construction practices, and putting it into the execution stage to get that desirable. This particular project is very dear to us. It's a special need individual school come assisted living in Somanhalli, very near to Chikballapur. This is a 7-acre site and 5 to 7 acre site, and here we have 4 different blocks. So we'll talk about the design parameters, then we'll talk about the technology that goes into the sustainable aspect, and then how it is being executed on the site. So when I talk about the design aspect, so we cannot jump in and put the sustainable features and all the technologies. It has to be conceived and it has to be put down right from the right basic stage. So when we started with the designing of this entire campus, so we were very much aware of the fact that it is for special need and for assisted living. So we had a very natural and very sustainable organic palette to work with. We started with the designing, keeping the basic parameters, keeping the natural sun movement diagram intact, and providing maximum shading and reducing the solar heat gain. If you look at the building, all of the classroom, there is classroom in B and C building, the accommodation block is A, and the D is the outreach center, where the SNI students, they meet the volunteers and the other people who come and learn and also teach them. So all of these classrooms are intact and they are north oriented because north doesn't receive any kind of heat. And whereas the accommodation which has senior citizen living, it has south orientation, but there's multiple shading which has been done into the compact planning. Also because there is a water channel running across, the idea was that whosoever doesn't feel like leaving the room, they can have a clear, beautiful view out from the window. So the entire designing process, we looped around 3 major concepts. The first concept was to keep the sustainability and innovation intact. The second aspect was universal design. So we maintained that each space should be accessible. Even the width of the toilet doors, which is standard, we just made it at international style so that it can be wheelchair friendly. The material palette that you see is anti-skid and very much very much these stones, these sandstones and these metamorphic rocks, they are easily available in southern Deccan Plateau. So we used all of these. The aspect that was followed was local procurement. We chose the indigenous plant. We worked intensively on water and energy conservation, not just rainwater harvesting system, but we also worked with a German technology that allowed us to collect the water and inject into the aquifer. Then the third was waste management, in which we had eco STPs installed. It's in the construction stage right now, but that was the proposal. And then natural ventilation, abundant amount of courtyard running throughout the site to maintain a visual boundary, visual balance, making a connection, and of course providing sufficient daylight. So these are few images that I'll just take you around so that you understand how it went. These are all the facades which are facing towards the southern or western side, which has long protruded windows and overhang balconies. This is a small video in which we take you around the site to understand how material selection can cut down the energy consumption of a building. This is the bird eye view. This shows that all the surfaces which are exposed to the sunlight, it has been well cladded. The southern side is cladded with ceramic stones, and the other places, the one that you see in the western side, it has vaulted roof and it has buffer slab to reduce the heat gain from the terrace. So when we started doing the designing, we just could not, there had to be a method to calculate what a very conventional building consumes, what is the energy that a conventional building consumes. And when we are designing with such kind of material palette, with terracotta jali, with porothum blocks, so what can we achieve? So we started measuring that. There are numerous softwares like Ecotech. There's a software by Bureau of Energy Efficiency. There's a software by Griha and LEED also, in which we run these buildings to understand the conventional energy consumption, and when doing the correct measure, how do we bring it down to 40%, 30%? So the entire building, which was exposed to the harsh sunlight in the southern and western direction, it has porothum brick. The brick is 8 inches thick, and there is an insulation, there's a cavity in between, which reduces the heat gain to 2 to 3 degrees, which is huge. There's a courtyard at the center, and that is the point in which our invert level is to the maximum. So we have inserted a injection chamber there, which recycles all the water from the site as well as from the roof and percolates it to the injection chamber. So here we had to always screen and keep the two different categories separated as well as visually connected. This is the residence for the senior citizen, and the school in which the SNI individual would be staying, those are the children. So although parents as we are, we always want to look at what our children are doing, but there should be a visual boundary as well. That is the screen that we see, and each places we have the sit-out areas where even if one is walking or using a wheelchair can sit down, relax, and then take a route further. This is the solar gain that we had got after getting it done in the software. And after introducing solar panels and shading at different level, we were able to cut it down. We have analyzed the solar gain from each facade, from each side. This is the data that we present. So this is the data that we receive. And then by providing sunlighting by providing shading on the roof, by providing solar panels on the southwest direction, we are able to cut it down to that level. So you can see the two levels that we have written down. One is the conventional building, and one is the level which it gets reduced to after getting the proper construction technology implemented into the design. So red being the hottest and blue being the softest. So we use the material, we use the technology, we use a lot of passive cooling techniques and shading devices to bring down the temperature. This is the courtyard that I talk about, and these are the bay windows, which are constantly shaded so that one doesn't get the glare directly, and neither the heat from the direct sunlight enters the room. This is the central courtyard to enable maximum utilization of daylighting. We had series of courtyard running all across. So this is a technology that we have introduced in which the lowest point of the site, we have introduced injection chamber. The injection chambers are little different than recharge pit. Recharge pit recharges the surface runoff coefficient, but at the end, when it rains for 2-3 days continuously, there is a saturation level. So when we are doing this kind of thing, it goes much beyond that. There is a research plant, and then the pit goes all the way to the aquifer. So first, we do a study of the aquifer and the hydrology of that system. It's well calculated, and the places which has some soft lock penetration, we provide this pit there to take the water inside. The side picture in which the injection chamber is being installed. It's right at the courtyard. The idea is always that we should take back something and we should return it to the Mother Earth. We cannot keep consuming and just, taking away. We have to, at some point, understand that we have to give it back. If not back, then at least, substitute the taking away part. So this is a typical section of the injection chamber that we have introduced. There is a desiltation unit so that all the waste, the leaves, and everything, small thing that gets separated, and the pure water gets inserted inside. It's put right at the center of the courtyard. This is the second project. So that project we spoke about the climatic zone of Bangalore, which is quite moderate. We have summer, of course we have summer now, but again it's a very moderate kind of summer which we have here. This project is one of the government projects that we are doing in Nalanda in Bihar. This is a 10-acre site in which the site is very arid. There is lot of water. This area has semi-dry, semi-drought kind of situation. So what is the best practice that we can involve here in this project? Because if we are giving a solution here in Bangalore, it might not work for another climatic zone. So here, this is a beautiful site next to the Nalanda Heritage UNESCO site. We have tried to create the building, that is the hatched part is our building. We have tried to create a we have tried to create a visual boundary accessing the heritage zone. The left-hand corner side is the UNESCO heritage site. So we tried to create a corridor connecting all the ancient Jain temples, the Buddha temples and the Hindu temples, and connecting to the sites. So this is the place where all the visitors would come. There would be a knowledge transfer, there would be awareness taught to them, and then the entire tourist movement would start. So this is the blocking that we started doing. We understood that this is a project in which we had lot of discussion happening that how should we proceed, because there is a UNESCO heritage site next to us. So we went with a very small module, the concept of mandala, in which a small pattern is repeated multiple fold times in a very dignified way to get a secret geometry. That is a design process involved. So there has been constant process of giving shading a prior thing. We have been constantly trying to create void in the southern and the northern direction, southern and the western direction to shade it. This is the building that we had designed. It has a water body right at the center. The mass is in a way that all the water floats from the roof and gets down to this chamber. Again, a recharge pit and injection chamber is installed here. This is the 3D image that we want to project. So all the vaulted roof that we see, it has a gutter system connecting to each other so that water, even a drop of water, is not wasted. This is a typical section of the gutter. When we started analyzing this in the softwares, we understood that if we shade the southern side or northwestern side, then what is the achievement that we can gain? And this is the shading area that we had designed for incorporating the solar panels. This is the yellow shaded area. This is again the chart. So this is the calculation which we want to show, that if we are doing a building which has this standard calculative amount of water consumption, if provided well, if we are doing the surface recharge, we are counting the runoff coefficient and doing a analysis, then we can bring it down to net zero. That is what we try to achieve in this building. Similarly, the energy calculation, because we have the solar panel installed in the southern and southwest direction, so we were able to cut it down also. The idea to present here is that we have solutions. We have numerous solutions. It's that we have to start with collaborating number of datas. We cannot just talk about some technology or some practices. The practices, the construction practices, the technology and software, and the execution exercise, it needs to work together hand in hand to get the desirable product. Thank you. And this is a QR code, so we can go through all the datas and understand how this is working in real-time scenario. Thank you so much.